yanked on my hair. Like my baby hairs.
Your what?
Yanked on one of my baby hairs in the middle of me doing like a physics problem. I was like, no.
You're almost a grown woman. How do you have baby hair?
Everyone
Baby
does.
hairs.
But,
They're constant. You can grow new hairs.
so you're just saying that they're new? Not like hairs that you've had
Like
since you
hair
were a baby?
around my head.
Correct.
Yeah.
Hair doesn't last that long. Though I don't understand how. Yeah. Anyways,
I don't know.
I just never mind. We'll talk about it later.
Oh.
Okay.
Oh.
Write a formula for the function, then use the formula to find the indicated value of said function. Number 2. The height h of an equilateral triangle as a function of its side length s the height of an equilateral triangle of side length 3 meters.
So since this isn't physics, we're not gonna have to do any conversions, right?
Negative on that. Okay, so equilateral triangle. Let's get a visual here. That doesn't look very equilateral. That looks better. Algebra 2 class, I would like write the answer and then I would like box it, but they like couldn't see what I was doing, and so like they kept being amazed at my perfect box, and they like didn't understand.
Whoa.
They were like, how'd she do that so perfectly? So then I tried to do it again, and it was like, it looked like that. They were like, there, and I was like, oops.
Okay.
So then it was funny. Every time I'd go to write an answer, they would be like looking down, and they would look back up, and it was like a perfect box. They were like, how is she doing that?
Wait, which class was this again?
Algebra 2.
You can only do it when they're looking away.
And so then the next one, they were like, we're not going to do this problem. We're just going to watch her. So I didn't box the answer that time. And then they were like, so then I went back and boxed it, and so he was like, ha, I caught her. She's cheating. And so then I was like, watch this. So then I did the triangle. They were like, whoa. Then I was like, circle. And they were like, whoa, how'd she do that? And then I was like, wait, guys, watch this. And so then I did that. They were like,
so confused, and I would look up and like, you would just, like,
whoa.
erase it so quickly. How did she do that?
And then I showed them this one, and then they asked me to do the problem in this.
So magic.
They were like, that's so cool.
It almost looks like a pumpkin, like you're missing an eye. It's so cute. What a cute pumpkin. Someone needs to design that, a pumpkin this year.
I'll save it. I'll do it.
It'll be the calculus pumpkin. I love it.
I kind of don't want to erase it now. I kind of just want to like leave it and draw a pumpkin around it. We'll do that later. Okay. Anyways, so back to my triangle. So my side lengths are all S, obviously. And then I have the height here. Whoa, not there. Hello. Right there. here. Yep, thank you. Okay, close enough. Is H. What do I know about an equilateral triangle?
So like all the sides are the same length and the what's it called thingies, the angles are all 60 degrees.
So if this is 60, what's this one?
Are you talking about the thing between the height and the side?
Yes.
That's 30.
So that's a what triangle?
One of those 30, 60, 90.
A 30, 60, 90. So I'm going to visualize here. Well, it's a little crooked. Just disregard. I'm going to visualize a 30, 60, 90 triangle with side length S. So what do I know about the base of this triangle comparatively to this? Like this is like this side of this triangle.
So like the yeah.
So this will be 1/2 S. And what do I know about this side over here?
It's
Like, is it like root 2
isn't it
S?
the same length as the hypotenuse or no?
No.
Oh, that's always the longest.
Yeah.
Okay. Sorry.
What are the sides of a 30, 60, 90 triangle?
I think that one's like, I don't know.
Is that the one where there's like the square root of 2 somewhere? Or is that something else?
No.
Oh.
That's the 45, 45, 90.
So is this one like square root of 3?
That's one of them, yes. So is that the one that you're saying is this side?
Can we multiply it by S?
I feel like I just broke him.
I don't know. I've been broken before.
Aw.
I've had many errors in my time.
So,
So should we add an S to that root 3?
that would, yeah, probably be a good idea. Just for the sake of, I'm more so, in this case, I'm more so just referencing like what that would look like. But yes, that would probably be good to, I keep trying to write it on my paper instead of like on the actual thing. So, that being said, I need to find the height as a function of side length S. How might one do that?
Okay, yeah, I think you broke me.
Are we like plugging in the 3 already or not yet?
Not yet. That's like the second part. We need to do the other part first.
So, if we have root 3s, would that be more than just s?
Yes.
So that s, just like the plain
Well,
s.
let's look at it this way. 'Cause there's a little piece of information that I think we're kind of missing out on here. Just in a normal 30, 60, 90 triangle, that's not that. What are my side lengths? We already said one of them is root 3. What are the other two?
Like 1 and 2.
So it's 1, 2, and root 3.
Okay,
But what do we notice about this?
that's 1/2.
That's half, and it needs to be this. So if I'm taking half of this, what do I also need to do of that?
Half of that.
So really this should be this for that side.
Okay.
And thus this side would be 1, because it's normally 2 divided by 2 would be 1. Are we tracking?
Why would that side be 1?
So normally it would be 2, but we have half of this here
Okay.
instead of it being 1, so we have to take like half of it.
Okay, the errors are gone now.
So now I need to say what h is equal to.
Like root 3 over 2s.
Yep. So that's the first part. So then the second part is to actually find the height if the side length is 3. And so that would be 3 root 3 over 2 meters. And I will say, like, I think that's, like, probably the hardest one, just because it's, you have to do a lot of, like, inferring, kind of. I feel like Josh is not too sure about this situation. Come back to my pumpkin later. Number 4.
Wait, how'd you get the answer for H?
It's just this side is H, according to this.
where
So
you
basically
got-
I did the whole equilateral triangle, and then I split it in half because I need height H of that. And so then I just broke down this piece. Basically I covered up this side of the triangle and I just worked on this side.
Oh, and then you plugged the 3 in.
Yeah.
Oh, okay. I forgot about that.
So 4 is the same type thing. Volume of a sphere. I'm not going to write out the entire problem. I'm just kind of abbreviating it. Volume of a sphere as a function of radius. And radius is obviously r. And then the volume of the sphere for radius equal to 3 centimeters. I'm just going to do that so that I can shorten it. Now the $1 million question. What's the volume of a sphere?
Like, I feel like there's about 4 in there.
Is it like,
And like the pi
yeah.
are
You almost got it.
4/3 pi r cubed.
4/3 pi r cubed.
I knew that one of them had the 4 and one of them had the 4/3. It's just which one.
So I'm going to go ahead and tell you now, there is a ton of volume formulas that you are going to need to be familiar with. Not for a couple chapters, but that you're going to have to know because they do not give them to you on the AP exam. So like volume of a sphere, cylinder, cone. I'm going to say like a cube, but that one should be pretty easy. But those kind of things, like you have to know them. So I would just like potentially start committing those to memory if you don't already know them because, and there are a couple of them that I'm going to be honest, I have to look up still because I mixed them up or whatever. But for the exam, there's potentially some word problems you may have to use them on that you won't, they won't give them to you. Anyways, okay, well, that happens to already be in the form that it wants it in, so we don't have to do anything to this one other than plug in the 3 for r. So
That's nice.
v equals 4/3 pi times 3 cubed. So what does that give me? You can leave it in terms of pi.
So 3 cubed is 27.
36.
36 pi. I just 3 and made this a 2 and did 9 times 4, which I'm assuming is what Virginia did.
Yeah, I was in my head doing the little, what's it called? I don't know, canceling out. So it means like, like finding it in terms of something, so like, does that just mean I have to have r somewhere in the equation so I
Yeah.
can plug that number?
It's like if, like normally we write a function like in terms of x. So it's like y equals something with an x in it. So this is just like whatever that variable they say. So if they said instead find the volume of a sphere as a function of radius x, instead of putting r in that formula, we would need to put an x.
Okay.
So it's just whatever the variable is for that given situation.
So we're the only class that has cookie points so far. Yay.
And nobody's
Why are we
asked
saying
about
yay?
it.
Why are we saying yay? That's like, yay, make mistakes. It's so mean.
All right. Identify the domain and range. Sketch the graph of the function. So we'll kind of like think through what the graph would look like and kind of do like a little rough sketch, but it doesn't need to be like perfect or anything. So 6 is y equals x squared minus 9. So what kind of function is this? Or like what would the graph look like? Huh?
Well, yes.
Parabola. I was right.
Yeah.
Yeah,
It's
I just said it the short way. You.
Oh, I thought you said cube.
No,
That's
I
why
said
I was
U.
like,
Yeah, I was like.
No, I was like, it's the shape of a U.
yes, it's a parabola. So, or, you know, if you want to be specific, a quadratic function.
I mean, I
But-
was gonna say that, but then what's the shape of it? So it's like U.
So, what is the domain? So, what are all the x values that this takes on?
All of the above. Well, all real
Negative infinity to infinity. Or you could write it as all real numbers. But the book writes it in the interval notation because pretty much everything with this you have to do in interval notation. Now, we need to look at the range, which is something we haven't done a lot with typically in the past because it's not as big of a deal until you get to this kind of stuff. So, what happens to this graph?
So it'll only go up on like both sides. Like it goes up in the negative and it goes up in the positive, but it starts out at -9.
So it's like the y is increasing.
So the whole graph would normally start on the x-axis, but that -9 has shifted it down 9.
Mm-hmm.
So that means that my graph roughly looks like, I'm going to call this -9, looks like this, essentially. And so when I say like draw a rough sketch, this is what I'm looking for. So based on that, what y values does this graph take on? That's what range is asking.
From like -9 to positive infinity.
Yeah.
Yep. So we would write this with a bracket because we include -9 on this one to positive infinity.
I wonder if it'll make your brackets look nice and fancy if you
It
try
doesn't.
it.
I've tried. Unless they've updated something. No, it does not.
Well, I mean that one was pretty good.
Well, that was just a freehand one.
Yeah, I know.
All right, number 8. Y equals negative radical negative x.
Oh, the horrors.
Now, in general, what does a square root function look like?
Like it kind of just like starts from like the origin, and then it kind of just goes out-ish.
It's kind of like, wee! Oh, that didn't do it.
I don't think it's like that.
Kind of goes like that, right?
Yeah.
Starting at the origin. Okay. Well, this one is a double negative, but in two different senses of the word, right?
So this one does not become a positive.
No. So, I would suggest we attempt to put a couple points on the graph first to see what it looks like. And I would do things that we know the square root of. Like, I wouldn't choose 7 because we don't know what the square root of 7 is. Okay?
I was gonna say I don't think we're gonna see anything, but then I think about it more and it's like, oh,
Now, there is a negative sign under the radical. So what kind of numbers do you think we might need to choose?
Do it, Virginia.
I don't want to say the wrong thing.
Well, say the right thing then. Say it louder.
Negative.
Yes, we need negative numbers because if I choose positive numbers, it becomes non-real. Pointing to the poster up on the ceiling.
Oh.
Oh.
I didn't get that.
Yeah.
I was just looking up.
So if I put in a -4, because that's something I can take the square root of, where or what do I get out? Like, what's the y value for if I plug in -4 for this?
-2.
-2. So at -4, it's at -2. If we wanted to, we could go to -1, which would give us -1. And obviously at 0, it's 0. So that means that this graph looks something like this. So the negative on the outside causes it to flip one way, and then the negative inside causes it to flip the other way.
Do you know which is which? Like which one caused it to flip upside down?
The negative on the outside would flip it upside down. The negative on the inside flips it over the y-axis. So, that being said, now using this, what would my domain be?
-infinity to 0 with 0 included.
Yep. What about the range?
0, -infinity to 0, it's still included.
Yep.
So does the point just stop at 0? Like is
Yeah, because anything greater than 0 in this case, so like anything to this side, even 0.00001 is still going to cause this to be a negative under the radical and non-real.
okay.
You can put it in the calculator, make it
Let's get a little crazy.
Ooh, crazy.
Number 12. Y equals 1 plus 1 over x squared.
I don't like this.
Virginia
sounds
said,
crazy.
I'll let you take the wheel on this one, Josh.
Whenever I have a fraction, what should my first thought be to do?
Asymptote.
Find the asymptotes.
Oh.
Does this have any vertical
I
asymptotes?
thought you said you were gonna let me take the wheel, Virginia. See, look, it even says.
Instead of Jesus take the wheel, it's Josh take the wheel.
No.
Well, I mean, it does say Virginia.
That is
so I
my
guess you
name.
should do this. It's your turn.
Okay, those are the bottom ones, right? Oh, it doesn't have any. Wait, 0.
Set the denominator equal to 0 and solve, so 0.
0.
So I know that at 0, essentially, it's the problem child. Are there any horizontal asymptotes?
No. Because bigger on top. Right?
Bigger
Because of 1 over
on
0.
bottom. No.
Bigger on
Bigger on top,
bottom,
there's
y
not.
equals 0.
Bigger.
I thought
It's
On
it's the variable ones.
Bigger on bottom.
Oh.
See?
So there's an x squared on the
Wait,
bottom
what's
and
Zero.
the top one? What is
bigger on top. No, there's not. But this
What
one
is-
isn't bigger on top. This
Yeah.
one's bigger on bottom.
Oh.
So
Oh,
there's
it
a-
goes by the exponent.
You
Well,
just
the
figured that
variable with the exponent, yes.
Okay.
I mean, I guess you could have.
So there's a horizontal asymptote at y equals 0. So that may or may not be helpful, but it's good to think about at least in terms of since we need to graph it, or at least roughly graph it. I know that there's no reason for me to plug in 0 because nothing's going to happen. So I'm going to draw in my asymptotes here so that I know that they're there. All right, so you may kind of have an idea of what this looks like briefly, but let's plot a couple points and see. So if I plugged in 1 for x, what do I get? 2. If I plug in 2 for x, what do I get?
1.5.
1 1/4.
No. Yeah, 1.25. Sorry, I forgot that squared thing.
How about if I plug in 3?
1.
And then 9.
Yeah.
So I know that roughly, based on what these points are doing, this is going to do something kind of like this on that side. But let's try a negative number just in case, because with the asymptote, sometimes things start and stop or whatever. So if I plug in -1 for x, what do I get?
2.
How about -2?
1 and 1.
You got it right this time. So that obviously shows me that it's mirroring what happened on the other side. And so, oh, I missed the dot. Just disregard. I'm going to move the dot. There.
It's like not even there.
So that being said, what would my domain be?
I feel like it's like from negative infinity to 0 not including, and then we do like the union thing, and then 0 not including to positive infinity.
Yep. What about the range?
I'll let you take this one, Virginia.
It's going from. Let me think. It's going from. It never touches 0.
Does it ever touch 1?
Yes. No.
What happens if I plug in 10?
That's 1 and 100.
1 and 100th. What happens if I plug in 50? 1 and something, right?
Yeah.
So that means it's never touching 1. I also know that because this has been shifted 1.
So
I mean, you might as well just have a horizontal asymptote at 1.
would it just
Yeah.
be like 1 to 1 not included to infinity, or is it?
Yes.
Okay.
Had to register.
That's what I
We
would
don't
do.
have this very often, but I'm thinking about it. The horizontal asymptote might actually be at 1 because it shifted. But if we didn't have that, then it would be at 0. That doesn't happen a whole lot. I don't know. Just don't quote me on that piece at the
Okay.
moment.
Sounds good.
I was more worried about the vertical asymptote portion, and then I was like, yeah, we'll just do the horizontal one too. Okay. Ooh, good question. Determine whether the function is even, odd, or neither.
I was not good at these.
Try to answer without writing anything but the answer.
Oh.
We're gonna show it.
So we're just gonna disregard instructions?
Yes, absolutely.
Love that. Oh, I just wrote 14. I was expecting you to just go to the next one. And then
14 through 20 are literally the same kind of problems as these.
Oh.
They're
Well,
just
I did it
slightly harder problems, so I'm just not worried about those. I might give you like 1 or 2 of them to try like on your own when you're doing them, but they work the exact same way as these. Okay, 22, y equals x plus x squared. And I want to know even, odd, or neither. At initial glance, what do we think?
Even.
Odd. Wait,
Okay, well, let's mathematically find out.
It's probably even.
It is.
let's
Oh,
plug
no.
in negative x
I changed my answer.
plus negative x squared. And what happens?
Well, the negative x squared goes to a positive x, but that's a bigger thingy, so it'll just continue to go in the positive.
I still think it's odd.
How about
Or
neither?
Neither, yes, because both terms.
The whole thing has to become, or the whole thing has to change signs. I don't like saying become negative. When you first learn it, they say become negative, but really it just means the whole thing has to change sign or the whole thing has to stay the same signs. So in this case, it would be neither because they're opposite signs. Like one changed
I
and
don't
one
like
stayed
that
the same.
X. So mean. Made me wrong.
26.
I'm almost as mad at that x as I am at that child.
Y equals x plus x cubed.
Odd. What do you say?
Yes, odd.
I thought you were just gonna say yes.
So negative x plus negative x cubed gives me negative x minus x cubed. So then I can take out a negative so that I can visually see it's x plus x cubed, but the whole thing has become negative, so the whole thing changed signs. So this would be odd.
Yay.
Now, 30.
Ooh,
Y
30.
equals 1 over x squared minus 1.
What say you, Virginia?
What?
I said, what say you, Virginia?
I am.
I thought we weren't supposed to work it first.
I don't care.
You cheater.
I can't think of all that at once.
Well, think. You have a
Well-
brain for a reason.
I am going to say.
I'm gonna say neither.
I'll say positive.
That's not an option.
Oh, wait, what's that?
Even,
I
odd,
was
or
actually-
neither.
Actually, looking at
I
it
say
again, I say
even.
even too.
I rescind my other answer. I say even.
Same. I say even
So this
too.
becomes 1 over x squared minus 1, which is that the same thing we started with?
Yes.
Then it has to be
See,
even.
I knew what I was doing. I had an alto moment.
The term isn't even alto, it's alto.
Whatever. Close enough.
And no, men are not altos. That sounds like feet.
Alright, 1 through 29, every other odd. I don't think the 1.3 notes are too terribly long. Did y'all already do them?
I didn't.
Okay, I was just wondering.
Did you? Yeah, neither did I.
If y'all want to do that for the next 10 minutes and just wait and do this homework like for Friday, so you don't have to do, I mean, if you want to do it, you can, but,
I get it out of the way now.
I mean, I'm gonna study for that quiz.
oh yeah, that too.
I'll do that